In case you're worrying about a problem involving exponents and rational exponents and negative exponents that has multiple steps, let's try this number 19 extra practice. You can see that I already changed the 32 to a 2 to the fifth, and that's because I have a fifth root here, and it's just going to make things a lot nicer later. Now, if you remember your order of operations, exponents comes before multiplication and division, so you must deal with this negative 4 fifths before we do anything with the 48x cubed. So let's begin there. I'm going to change that as I've written it. I'm going to change it to 2 to the fifth, and I have an x to the fifth. And we are going to apply this negative 4 fifths. We're just going to send it in and send it in. So we're going to get a 48x cubed. So I'm going to multiply this by negative 4 fifths and this also by negative 4 fifths. Now, if we clean this up, we get negative 20 over 5, which is negative 4, or you could just cancel the 5s out. So we're going to get 48x cubed times 2 to the negative 4, x to the negative 4. All that means, all these negative exponents mean, is that the 2 and the 4, the 2 and the x belong down in the denominator. So what we're going to do is we moved them down there, they become positive, and this is now gone. Now all we have to do is clean it up and start canceling things. So I've got 48x cubed, and that is all over 2 to the fourth, which is 16 x to the fourth. Okay. If we're not supposed to have any negative exponents, you could do this using the subtraction rule, or you could say, I'm going to cancel out all 3 x's on the top, and I'm going to have to cancel 3 x's on the bottom, leaving me with just x to the 1. And the 48 and the 16, just cancel as usual. 8 goes into 16 twice, and 8 goes into 48 6 times. And you can see, oh, shoot, 16 went into 48. But that's not a problem. 6 over 2, that's just going to become 3. So your answer is 3 over x. Now for number 21, just in case you're not sure how you would evaluate something like this, especially if we said you couldn't use a calculator, what you would want to do is you would want this to have the same base. So we've got a 4 and an 8. We can't really use our rules of exponents to do anything with this, and we're certainly not going to find out what 4 to the 28th is. So what we're going to do is we're going to rewrite 4. So I'm going to get rid of this 4, and then I'm going to, oh, it doesn't want to get rid of it. There we go. And 4 is the same thing as 2 squared. So that's what I'm going to write. Now, can I write 8 in a similar way? Well, yes. So I am going to get rid of this 8. And I am going to likewise turn that 8 into 2 cubed. And now I can just use my normal rules of exponents. When you take an exponent and raise it to another one, you just multiply. So this is going to become 2 to the 56. And same thing here. We're going to do 3 times 17. We're going to get 2 to the 51. And now we have the same base. So just like when you have like x to the 56 over x to the 51, we can do some canceling. We can cancel all of the 51x's down here and cancel 51x's up here, being left with 5. So we're going to try that with our 2's. We're going to say 2 to the 56, 2 raised to the 56 minus the exponent on the bottom. And you get 2 to the 5th. And you can evaluate that with a calculator. Remember, just keep doubling it on your fingers. The first 2 is 2. Double, 4, 8, 16, 32. So 2 to the 5th is 32. And for our final problem, we're going to do we're going to rationalize the denominator. You could multiply the entire bottom by the 5th root of 4x cubed 4 more times, but that seems excessive. So what we want to do is we want to fill up the radical with things that will be perfect 5th roots. So you can see I changed the 4 to a 2 squared. You've got 2 2's being multiplied. We need it to equal 5. So I think a lot of you can see, well, we would need 3 more 2's. So we're going to multiply by 2 cubed, which is 8. And as far as the x is concerned, we have 3, so we need 2 more x's. We need x squared. So we're going to multiply the top and the bottom by the same thing. So here we go. Let's get this and put it up here. And now what we're going to get is 3x times this whole mess again. I'm going to multiply one more time. We have 3x times that. Make a little 5th root. And on the bottom, let's clean up what we've got. If you have, now we have the 5th root of 2 to the 5th, x to the 5th. These are going to cancel out. We're going to be able to take out a perfect 2, and we're going to be able to take out a perfect x. So our problem looks like 3x times the 5th root of 2 cubed times x squared all over 2x. I think a lot of you can see that we could cancel out the x's already. So let's do that. X's are gone. So now taking what's left in our radical here, we're going to simplify it. So 2 cubed, we wouldn't want to leave it like that. We would actually write it as 8 and x squared. And that's your final answer.